W1VLF.
Hey everybody, my name is Paul and welcome back to the W1VLF lab. Today we're going to talk about a battery charger. This is a battery charger for an electric vehicle. Actually, it's for a bicycle. And a couple of friends of mine, Rich and Charlie, DF'd this noise source. It was specifically on 40 meters for them, but it was all over the place. Covered quite a bit of frequency range. Anyway, here it is. I'm going to give you some close-up shots of this later, but first, got my sheet here to talk about with all the things that went wrong with the video so far. I made a couple of videos over at the ham bench, and I messed up on the audio level in a couple places, so it gets really loud. It gets kind of scratchy on voice peaks, and it's too damn hot. It's 97 degrees. I'm standing here barefoot because it's so freaking cold, so hot out. So I wanted to apologize for that. The other thing is I refer to this thing a lot as a power supply, and it's not. It's a battery charger. Don't know why I was getting stuck on that. I think it's because I was using a 50 ohm resistor as a load. The other thing is I refer to this as capable of 20 amps. It's not. That's the battery capacity, 48 volts at 20 amps. And this is actually capable of 2.5 amps. So you'll see a bunch of testing and how the noise increases with load. You'll also see a bunch of mitigation devices, one of which is this really cool Nanolux filter. These have been around for a long time. They're EMC filters. I'll try to put a link somewhere in the description. They come as a pair. Unfortunately, you can only use one of them. This is the AC side and the DC side. They're used primarily for quieting down grow lights and RFI, but they're quite effective in lots of other applications. I've used them quite a bit. So let me just see, is there anything else? Yeah, this is sort of, you know, at work I have equipment where I can look at noise, conducted noise from a power supply, battery charger, LED light, whatever it is, and I can say yes, no, FCC Part 15B, it passes, it doesn't. But that's not real world. This is real world. So when Charlie and Rich asked me if I wanted this supply to look at, there we go again, this battery charger to look at, I initially said, no, I'm not interested. And I said, wait a second, hold on. Let's see what the real world, what we can really do here with common mode chokes, with EMC filters, and blah, 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 a whole bunch of other stuff. So at the end of this video, we're going to go over to the bench in a couple of minutes, but when we come back, we're going to crack this baby open, and I'm going to take some pictures of it and show you what the real issue is. A lot of times in a really inexpensive imported battery charger like this, there's a couple of things that are eliminated. One of them is the EMC filter on both the input and the output, because both of these sides can radiate. I only put the filtering on the input side because that actually has the bigger antenna. When you see this thing, when you see the level of interference that I have, bear in mind that I'm using a 6-meter antenna on my tower as the antenna for 40 meters. So the noise floor is really low. It's like minus 120 during the day. You know it's not supposed to be that low unless you live out in the middle of nowhere. So any numbers that you see relating to levels pretty much are significantly worse than what you're seeing. I'm not sure. I think that's it. That's all I wanted to say in this. So after you look at these videos, and again, bear with me. I'm not obviously not a pro at this. Just whatever comes into my head goes out my mouth. And it is really hot. So I'll show you a close-up picture of these common moat chokes. These are snap-ons. I don't usually like to use snap-ons, ferrite cores, because you can't get many turns through them. I was able to get 4 turns through each one, and it worked well. These are material 31. I have some, and these are the only 2 that I had, so I really would have liked to take a 2.4-inch core and wind 10 or 12 turns through there, but I couldn't. And I probably would do the same thing on the DC side, since there's, even though we got rid of what's coming out on the AC side, there's still a lot of junk coming out the DC side. Granted, this is a pretty small antenna going to the battery compared to, you know, the AC line cord and everything in your house. So anyway, I got shots of all these. I'll do a voiceover and experiment with them. But for now, we're going to head over to the ham shack. And that's it from the Group W bench. Okay, so we're over at the ham radio bench here on the computer. And we're looking at 75 meters. Now, I'm using my 6-meter antenna for this experiment because my HF antennas are not up in the air yet. And you can kind of tell for midday, the average noise level is sitting down around minus 130 dBm, which is actually really, really low, with lightning crashes up to 125. But there's still plenty of signals to listen to on 75 meters, or excuse me, 40 meters. Let's see what we have right here. Okay, so right now the battery charger in question is off. It's over on the Group W bench with all the filters and stuff ready to be installed. And I wanted to show you what the noise floor looks like and exactly, you know, listen to some of the signals. Let's see, let's tune this guy in. There's not a lot of activity here at midday. Somebody with some nice chirp. Well, I'd like to find somebody nice and strong. Okay, so there's somebody. I'm going to pause the video here right now and go over and turn the power supply, or excuse me, battery charger in question on. So I'll be right back. Okay, so the power supply, excuse me, why I keep saying that. The battery charger is on right now. And look what happened to our noise floor. Is up well over almost a minus 110 depending on where you go. And these carriers are 10, 20, 30 plus dB out of the noise. So this is what Charlie and Rich were up against. For some context, my antenna is 175 feet away at the top of a 125-foot tower. So whatever the hypotenuse is, that it's a few hundred feet away distant from this power supply. So I'm going to go over to the AM mode for a minute, and you're probably not going to want to hear all that crap. Give you an idea of what it sounds like. Let me turn that down. Sorry about that. So we have like a minus 85, minus 86, something like that. So I'm going to go over there and I'm going to put in, first I'm going to put in the commercially available EMI filter rather, and it's kind of a stock item that you can get off the shelf. And let's see what kind of a difference we can get with just that. Let me center this up. Turn that down a little bit more. And we're coming in at somewhere around minus 86. It changes slightly. And the other thing is, look at this. This guy is not stable. Look where he is. He's all over the place. Another point. That's why I keep calling it a power supply, because right now I'm charging a 50 ohm resistor. This supply this power supply, wow, I keep saying that. This battery charger is capable of 50 volts at 20 amps, supposedly. That's what's written on the label. I am currently pulling 1 amp into a 50 ohm resistor to make these wonderful diagrams here. So here's what's going to happen. I'm going to go over there and I'm going to put in the line filter, and then we'll take a look at that. Let me just see if I can find somebody talking, so that we might have a better let's see, understanding of what's going on here, or be able to. I mean, visually is one thing, but to hear it acoustically is another. Here's somebody right here. He's on the side. He's on the side of the carrier of the noise right now, but that doesn't mean he's going to be there forever, because this, like I said, this thing moves around quite a bit. Let's zoom in a little bit more. Of course, there's nobody right on top of one of these carriers. That would be really help in hearing, trying to hear the difference. Well, I'm gonna go. Let me tune him in. He's gone. Let me go plug the mains mains filter in. I'll be right back. Okay, so you can see just by the waveform and the waterfall here, a significant decrease. Go to. So we lost down to maybe minus 100 at times, and you can hear it moving in frequency. So that was the first part, was putting in that line filter. Second part is I'm going to put a couple of common mode chokes on the AC line in addition to this line filter, right at the base of the battery charger where the power goes in. I wish we had somebody that was nice and that we could hear. All right, so we're at minus 96. I'm going to pause, and then I'll be right back. Okay, that's common mode filter number 1. Not a huge difference, but a few dB anyway. And I'm going to stick a second common mode filter, and I'll show you these afterwards. So we'll go through another pause here, and of course it's riding around all over the place. So we're going to pause, and I'll go put the second filter in, and we'll be right back. Okay, back again. And right in here is where I put in the second one. So there's a few, you can see it better over here. There's a few more dB of attenuation. Of course, it's off frequency again. So I guess we're down to minus 102 or so, 101, 102, 103. And I've got one more change, and that is I put a big number 75 core material donut on the line cord, feeding the EMI filter for hopefully another couple of dB. So I'll pause again, and I'll be right back when I make that change. Okay, I made the change right here. That's where I put the additional common mode choke on. So I don't think that made a heck of a lot of difference. I'll show you this equipment, or I've already shown you this because I'm recording this after or before I make the introduction to this. So let's try and find somebody and go back and listen to them and I'll take out the filtering. But you can also see that our noise floor has dropped back to somewhere around minus 125 or so. So let's see if we can actually find someone talking that happens to be right in the middle of one of these things. Eventually, everybody's going to be in the middle of one of these things because it moves around. Well, this guy's lucky. He's right off to the side. Or so I'm going to go pull that filter out right now. Let's look. I think I see somebody over here. Okay, I'm going to go pull the filter out live here. I'm going to go unwind everything, and you can see after everything's been done the difference as we come back. So stand by.
Okay, 7-3. See you today, brother. Glad you made it home safe. NAD today.
All right, we're back. Isn't that wonderful? As that thing drifts back in, we'll be back. So I think we made about a 25 dB difference. And that was putting common mode chokes on a real-world battery charger and what you might be able to expect, along with a filter as well. And I'll show all these things, or I have shown all these things when I do the introduction. So this is W1VLF standing by from the radio bench. Again, thanks to Rich and Charlie for sending me the power supply so I could do these experiments. Oh, one other thing. I'm going to crack this baby open after this battery charger. Wow, I got something going on here with the battery charger power supply thing. But I'm going to crack this open and see just what's inside and where they may have been able to put filtering and just omitted it, or we'll see. Some of these things have circuit boards with no filtering in them, line filtering, with places to put it. So I'm going to just drop this off. I'm going to run into the other room, unplug this so everything falls back to zero again, and that will be the end of this part of the video. So guys, I'm back again for a quick follow-up. I had mentioned that this battery charger is labeled to be as 50 volts, 20 amps. This is for electric bicycle charger. So here's the thing. Right now I'm only drawing 1 amp. And I'm going to go into the other room and I'm going to attach another resistor, and it's probably not realistic that it's delivering 1 amp. It's probably more like 5 to 10 amps. But I'm going to put another resistor on there so you can see the difference. Here goes. I'll be right back. Okay, so now we're up to minus 80, and look at that noise floor. Unbelievable. So imagine what this would be like living maybe 100 feet away from this. Just wanted to show you that last part. I'll go drop it back to a 1 amp draw, and then I'll finish this off. Okay, I'm back again. I just thought that was worthwhile, showing you just how bad it could get. I don't really have a way to load it to, let's say, 5 or 10 amps, but what you're seeing on the screen right now is the difference between 1 amp, which is currently supplying now, and 2 amps. I would venture to say that this thing is going to be pulling much more current than that on a depleted electric bike cell. Anyway, this is W1VLF 73 signing off from the ham radio bench. You know something, guys? I don't know. This is what you get when you get a guy with ADHD in front of the microphone. Forgot to mention this other thing. I wanted, you know, even when this thing is done charging, this is the battery charger just running at idle. So, you know, after this thing charges, it doesn't stop. It just keeps making this noise. Okay, granted, not at the same level. So this, I promise this will be the last part of this video, but this is the battery charger at idle. It's not delivering current to anything. Where am I? There's my mouse. Okay. I'm going to go and I'm going to add a 1 amp load, and then I'm going to add the 2 amp load. But even when the thing is done charging, this is just sitting there on the bench. No load. Here goes. I'm going to go add 1 amp and then 2 amps. Did you see that immediate shift off in frequency? This is why a lot of switching power supplies, when you load them, tend to move around in frequency. And look at the noise floor. It came up too. All right, I'm going to go add 2 amps and see what that looks like. Wish I could go more. Okay, another huge increase in noise, not only in the peaks, but especially across the noise floor. Let that sink in for a little while. And there's going to be more and more electrical vehicles, cars and bikes and scooters and all sorts of stuff like that. So once that gets about halfway down the screen, I'm going to go unplug it. Take the load off first and then unplug it. Okay. There it is, just idling. And look at as it cools down how it starts dropping in frequency. I think the fundamental oscillator in there is running about 50 kilohertz because this one is at 740. Nope, higher than that. 140 to 190. Yeah, about 50 kilohertz. And I'll go unplug it now, and I promise that'll be the end. Okay, back to Mother Nature's noise floor. Thanks a lot for sticking around with me, folks. If you want to see more videos, please subscribe. There's a little button in the lower right-hand corner of the screen that will allow you to hover over it, and then it'll pop up with a subscribe button. You hit that, and then hit all of the notifications, and you'll be subscribed. Nothing fancy here, just sort of real world stuff. 73 from W1VLF here in Harwinton, Connecticut. All right, I'm going to take this puppy apart, and can you imagine that? It has screws in it. Unbelievable. Before I get this apart, what I'm expecting to see is a circuit board with a whole bunch of components that are missing. Namely the EMI filter. Something like that. That's a really good one. But there should be a bare minimum in here, and I'm guessing that's not in there. A lot of times the circuit board is capable of holding the parts, It's stenciled in, but they don't put them in because that would make it cost another dollar or two more expensive. So instead, they just let it spit out noise everywhere. So, oh shoot, that was easy. Okay. So, whoop, doing this backwards. Here's the AC side, right? Follow this in. And, wait a minute. Oh, we can take it right out of there? Yeah, okay. So here's the AC side. And guess what's missing? LF2. You know what LF is? Line filter. And a bunch of capacitors that are typically across the filter to make it look like a low pass filter, so that 60 hertz can come in, and whatever this is running at, I think it's running at like 50 kilohertz, can't go back out. That's a real problem. Let me zoom out just a little bit. Okay. So that's the AC side, and on the DC side, yep, look at that. LF3 is missing. The inductors and the capacitors and a couple other components, it looks like, too. So there it is. It's on the circuit board. And you know what? You probably can't see this very good, so I'm going to take a couple of pictures close up, and then I'll narrate over the top of them. So that's where the filtering should go, and guess what? There's just a solid bar of solder from here to here. The holes are there in the circuit board. So basically, what do? You come in. There's one capacitor here. I'm not sure what that is for. They call it it must be. It's an X capacitor, so it's across the line. And the diode stack and a rectifier, and then you chop the heck out of it at 50 kilohertz or so. Rectify it again. Pass it through the transformer. Rectify it again, and send it out the door. But there's a lot of stuff missing on this. And I'm sure that this low-pass filter would have gone a long way. An important thing to remember here is, even though I was able to put a... There it is. I don't do this enough. Even though I was able to put a EMC filter on, it still is on the end of this cord instead of right here at the circuit where you really would like to see it. And the same over here. Alright, I think the best thing to do is to get some pictures of this up close. I'll do that, and I'll talk over those. So, okay, so I guess that's going to, no, that's not going to be it. That's going to be the end of the video, but it's not going to be, the end of the actual video. The rest of it will be some slides and things. So, and some, if you have any questions, give me a yell. Blah, 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 blah. And if you can, subscribe. There's a little button in the lower right hand corner. If you hover over it, it will bring up a subscribe button. And if you hit the subscribe button and then hit the notification all bell, that will get me up to 1,000. I think I'm at like 650 or 640 now. Would be cool to get to 1,000. That's like a goal, maybe before winter. Anyway, thanks again, and 73 from the W1 VLF lab. So here's the entire power supply as you see it, directly out of the case. I'm going to try to keep these audio clips short and get as much stuff done here as I can. Well, here's where the line filter should have gone. The back side of the circuit board showing the soldered over connections where the filter should be. Oh, and here's the back side of the battery charger. So in the event that you want to get one of your very own, here's the company that manufactures it and all the specs. Here's that Nanolux filter that I was talking about. I'll put a link in the description as to where these can be found. Again, there's this one, which is the AC side, and then there's the other side, which is meant for the ballast, the output of the ballast, which may or may not be useful. I don't know. I've never tried using that half of it. Here's another EMI filter made by Qualcomm that could be substituted. 3 amps, 120 volts. Essentially, look at the diagram. It just looks like a low-pass filter with some common mode capacitors and a ground connection. And finally, a common mode choke that you could wind yourself. This is on a 2.4-inch core. If you're considering doing this for frequencies in the HF band from a megahertz up to, say, 30 megahertz, the material here would be number 31. I don't like the snap-on cores because you can never get enough turns on the snap-on cores. Remember, the impedance of the common mode choke is a function of the square of the turns ratio, so you get something for nothing. 2 turns is 4 times the impedance of 2 turns of 1 turn, and 4 is 16 times. So the more turns, the better to a certain extent. It's not always true, but it is for all practical purposes. In this case, it is. Thanks a lot, guys. 73 W1 VLF.